Let us now proceed to series parallel circuit. Okay, a series parallel circuit is a combination of both series and parallel circuits within the same electrical system. In a series parallel circuit, resistors and other components are arranged in a way that incorporates elements of both series and parallel configurations.
So proceeding to the sample problem of series parallel circuit, we have here one. So the first thing you will essentially need to remember is that once you see this type of circuit, you will need to minimize it until all that's left is a voltage battery or the total voltage as well as one summation resistor. So it's the summation of all the resistors. So you add the resistance of each resistor into one, but you will need to consider the if it's parallel or if it's a circuit resistor. So the first thing I see here is these two circuits. So they're parallel, right? So in order to get R3 R3 and R34 is the summation of R3 and R4. So it's a parallel, right? So what we essentially need is add the resistance as you would like for a normal parallel circuit. So 1 over 4 ohms plus 1 over 6 ohms raised to the negative 1. So inputting that into our calculator, so 1 over 4 plus 1 over 6 raised to negative 1, it should be 2.4. So the resistance of circuits R3 and R4 is 2.4 ohms. So the next thing we do is redraw rather our new circuit. So it's just a draft, so doesn't have to be any kind of fancy drawing. So we still have R1 here, 2 ohms, and R2 here. So R2 is 10 ohms. And we have R34 here. So R34 is now 2.4 ohms. So now we see this, it's a series circuit now. So now we just turned our series parallel circuit into a proper series circuit. So what we do here is add all of these resistors right here and find their total resistance as you would do for a series circuit. So R1 plus R2 plus R34. So how do you normally add that? So just simply get the sum, right? So 2 plus 10 plus 2.4, and that would equal to 14.4 ohms. So that's now our R1, 2, 3, 4. So in a sense, it's like our total resistance. So drawing another circuit, our final draft that is. So still have 50 volts here and our RT, which is 14.4 ohms. So now we simply get the the total current. So how do we get the total current? So it's total voltage over total resistance, right? So our total voltage is 50 volts and our total resistance is 14.4 ohms. So inputting that into our calculator, we now have 50 over 14.4, which would simply equal to 3.47 amperes. So now that we have gotten our total current, we will have to trace back to our drafts, to our previous drafts rather. So I will just copy this first draft right here and then paste it right here. So we will now be working backwards. And so we see R1, R2, and R34 here. And our For series circuits, the total current is the same across all of the resistors, right? So 3.47 amperes, and it's the same with our ampere for R1, our ampere for R2, and our ampere for R34. So in a series circuit, all the current is equal to each other. So what else do we need to find? The voltage, right? So solving for each of the voltage, so the formula for voltage is V1 is equal to our I1 times R1. So our I1, as we can see right here, is the same 3.47 amperes multiplied by our resistance on R1, so, which is 2 ohms. So inputting that into our calculator, we get 3.47 times 2. That gives us 6.94. So the voltage drop for R1 is 6.94 volts, and computing for voltage number voltage on R2 is the same formula. So 3.47 amperes multiplied by 10, because that's our resistance, so 10 ohms. So our voltage drop on R2 will simply be 3.47 times 10, which is 34.7 volts. So 34.7 volts. And now for voltage R34, we will now multiply I34 with R34. So still 3.47 amperes. And then R34, our R34 going back is 2.4 ohms. So just write 2.4 ohms. And inputting that into our calculator, we will have 3.47 times 2.4. That gives us 8.328 volts. 8.328 volts. So that's our V34. V sub 34. So our only goal here was to get V1 and V2, and then we will now proceed to getting V3 and V4 separately, and we will compute for the power afterwards. So now copying the last draft back where we started. So let's just solely focus on this, okay? Focus on this. So we have a total voltage of V34, which is 8.328. So since it's a parallel circuit, the total voltage is equal to V3 and V4. So we have to solve for the current in each resistor. So solving for I3, it is V sub 3 over R3. So our V sub 3 is the same, so 8.328 volts all over R3, which is 4 ohms. So inputting that into our calculator, 8.328 multiplied by 4 is 2.08. So 2.08 amperes. And now lastly, we have the current on resistor number 4. So V sub 4 over R sub 4 is equal to the same thing. So 8.328 all over 6 ohms. So inputting that, 8.328 all over 6 is equal to 1.388 amperes. So now that we have this like collection of values, so we will now be inputting this in a table of values and then simply computing for the power and the total power, or what the problem needs. So we'll solve it all, and I'll just do the table, guys. So now that we've just completed our table, of values, the formula for power is equal to V times I, right? So we have the voltage here and the current right here. So we will now compute for the power in each resistor by simply multiplying all these values. So I just finished multiplying all of the voltages and the currents in order to get the power. So we have 24.09, 120.55, 17.32, 11.49, and the total power is 173.45. So this problem was actually getting for the power, the total power rather, and the power across resistor number 3. So we have our final answer. So we have our final answer of total power, which is 173.45 watts, and the power across resistor number 3, which is 17.32 watts. So that's about it. So as a challenge for you guys, so try out this more on complex series parallel circuit problems. So if you want, you can pause the video in order to have time for yourself to solve it, and we'll post the answer in a few seconds so you can solve it. So pause. So if you've done it correctly, here are the values on our table right here, which is solving for the current on resistor 5 and then the total power together with the voltage drop on resistor number 3. So here's the answer. If you got it correctly, give yourself a thumbs up, and we'll see you on the next problem.